We can throw like everything away.
Alright, yes, you can throw everything away. Alright, so. That's all.
And did you want the papers, like when we watched videos and you weren't here, that was a week?
Yes, I wanted them like weeks ago.
Oh.
If you have them, just turn them in. Alright, so now we're talking about atoms. This is our new topic. So let's think back a long, long time ago, like 2 months ago. I told you about this guy, Democritus, right?
Yep.
And he came up with the idea of the atom. He was the first one who we know came up with the idea. Probably there's some guy before him who got no credit. But he's the guy we give credit to. So Democritus said, basically he said, I think things are made of atoms. That was pretty much it back in those days. You came up with your idea of what you thought was true, and you went with it. And then this other guy comes along 2,000 years later, who we consider more important, John Dalton, 1766 to 1844. So he lived during the American Revolution, although he was English, so he thought we were the bad guys. And this guy, he showed that things are made of atoms. How did he show it? Through experimentation, right? He showed that things are made of atoms. Through experiments. And that's why he's more important, because he had evidence to support it. We don't say proof in science, we don't like that word, but he had evidence to support that things are made of atoms. Okay, so what is this idea of the atom? Well, basically the idea is you keep getting to smaller and smaller things, right? You take any object, you cut it in half, and you take that half and you cut it in half, and you take that half and you cut it in half, and you keep cutting it into smaller and smaller pieces. The question is, do you get down to this smallest piece, or can you keep cutting it in half forever? Can it keep getting smaller and smaller? And the idea of the atom is that there is that smallest piece, that there's nothing smaller than it. Today we're more specific. We say it's the smallest piece that still retains the properties of that element. But basically it's the smallest piece. Well, sort of. There are smaller pieces. Atoms are made up of protons and electrons, so there's smaller pieces inside of it. But it is sort of the smallest piece. If you get any smaller, then it's no longer what you originally had. So that's the idea that these guys had. And Dalton came up with some rules for it so that we could explain what is an atom and what atoms do or don't do. And this is called Dalton's atomic theory. There's basically 4 rules, and I will definitely ask you for these 4 on a quiz and a test at some point in the future. So number 1, all matter is composed of tiny, indivisible, what's that mean? That's so funny. You would die over it? What's indivisible mean? Can't be divided. You can't make it any smaller. Right? You can't cut it in half. Tiny, indivisible particles. And we all heard that, so you're not going to say the phone's ringing, right? Because everybody knows I can hear it.
The phone.
Indivisible particles called atoms. Now, when you tell me the phone's ringing, I remember your name, and then weeks later I throw away some of your work so your grade goes down. 8 to 25.
Oh, what's his name?
I got that on evidence.
Malika?
Ooh.
Ooh, no.
Ooh. Papa cares about this. What the hell did I do?
Malaysia, right?
Oh,
No. I don't think that person's in this class.
Yeah.
Okay.
We go shower.
All right.
I didn't do anything.
All right. Few exceptions here to this rule. Exceptions. The rule says atoms are indivisible. That's not exactly true. We see atoms divided in nuclear reactors and nuclear bombs. So atoms can be divided. Bigger ones can be broken into smaller ones. And even the smallest one can be separated into a proton and electron. So they can be divided. But usually they're not, only in nuclear reactions. All right, I'm running out of space here. Can I erase the top? Does everybody
The
got
top
that?
part.
Yeah, and
top
two
part.
Are you, where were you at? Are you caught up? Okay. All right, so let's get rid of this. You don't want to write there. All right, number 2. Atoms of the same element are identical. And atoms of one element are different from atoms of another. So, take a look over here at the periodic table. So, an atom of hydrogen, for example, is made up of 1 proton, 1 electron. Every atom of hydrogen is going to have 1 proton, 1 electron. An atom of helium has 2 protons, 2 neutrons, 2 electrons. An atom of lithium has 3 protons. So each one is different, and the ones of the same element are all going to be the same. The only exception is atoms of the same element can have a different number of neutrons. All right, exception. So, isotopes, that's what they're called. So if you have 2 atoms of the same element that have different numbers of neutrons, they're called isotopes. And we'll talk about that later. You don't have to remember. What?
Oh,
Isotopes of the same element have different numbers of neutrons. Has an I in it. What's going on over there?
What's that noise?
So, when the pipes heat up, they expand, just like everything expands when it heats up, and then they're attached to the wall, and so the pipes have to, depend like, as they expand, they contract, they make noises.
That was rats.
No, it's called thermal expansion. Okay, so that's it for that. So basically, an element, for example, an isotope of helium could have 1 neutron or it could have 2 neutrons. It's always going to have the same number of protons, because if it's a different number of protons, then it'll be a different element. But the number of neutrons can be different. All right, let me move on. All right. Number 3, atoms of different elements. You guys ever heard of heater before?
I've never heard one like that.
Another thing that happens inside the pipes is sometimes the hot water will flash to a gas and then it'll collapse on itself and you'll hear the bang from that. It's called cavitation. That's the right word. Atoms of different elements, what am I doing here? Can physically mix Physically mix means literally like you take two piles of stuff and you mix them together. Throw some sugar and salt together and stir it around. That would be mixing physically. Chemically combine. Chemically combined would be a chemical reaction. You might see fire or rust or something happening. So this will be two atoms come together and they stick to each other and they form a molecule. Or you have a molecule that breaks down into separate atoms, things like that. Or one atom goes into a molecule and displaces another. That's what this would be. Where am I at? In simple whole number ratios. Skip the comma. In simple whole number ratios. So this just means if you look at most compounds, right, you have water, for example, H2O, 2 hydrogens for every oxygen, simple 2-to-1 ratio. You could have, I don't know, N2O4, well that's 2-to-1 ratio also. Carbonate, CO3, right, so this would be 1 carbon for every 3 oxygens. So it's always small ratios, 2-to-1, 3-to-1, 3-to-2, things like that. With a few exceptions, like I think coal, for example, you see big numbers, 200 carbon, 400 hydrogen, stuff like that. All right, last one and we're done.
Oh, yeah.
Number 4. Chemical reactions occur. And I was kind of talking about this a little bit in number 3. When atoms are separated, joined, or rearranged. And there's more to number 4, but I want to stop for a second. So if you imagine, for example, like if these markers were atoms, right? So if I had 2 separate atoms of 2 different elements and they come together and they react, they form a molecule, that would be a chemical reaction. Or if I had a compound and this molecule breaks apart into 2 separate atoms, now that would be a chemical reaction also. Or if I already had 2 together and another one comes in or displaces one of them, that's a chemical reaction. This one's given off, we have a new compound. So that's how chemical reactions work. Atoms are sticking together, atoms are coming apart. Each time you're making a new substance, but the individual atoms themselves stay the same, they're just stuck together, so the substance acts differently and looks different. However, atoms are never changed into atoms of another element. Okay, and for number 4, same as number 1, the exceptions are basically any nuclear reaction. So you can just write nuclear reactions. So again, this would be anything that happens in a nuclear reactor, anything that happens when a bomb goes off, a nuclear bomb, or also what happens inside the sun. So in a fission bomb, for example, we see uranium break down into thorium and helium, and then thorium further breaks down into smaller elements. So basically big atoms will break down into smaller pieces. In the sun, we see hydrogen atoms come together and eventually form helium. So nuclear reactions can change one element into another, but for chemical reactions, we just have atoms sticking together and coming apart, but they stay the same atoms. So if hydrogen reacts with oxygen and it burns and you get water produced, you still have the same hydrogen and oxygen atoms, they're just stuck together now. So now they make a liquid instead of 2 gases. But it's still the same original atoms. Questions on any of that? All right, we are done. Everything that's in these things we're going to go into in more depth. This is just like the basic introduction.
Do you have to set that off or upload to YouTube?
You know,